Hello friends, this is Dr. M. Nilesh coming up with a new video that is of the amplifiers. In this, we are going to explore more about the power amplifiers. Now, the topics that are being covered in this are the brief history of the power amplifiers, classification of power amplifiers, circuit diagram and waveform of class A, class B, class C, class AB power amplifiers. So, the first is the brief history of power amplifiers. The power amplifiers was invented in 1909 by Lee de Forest, who also invented triode vacuum tubes. Triode vacuum tubes was used to make first amplitude modulated radio, and earlier power amplifiers was based on the vacuum tubes, but modern power amplifiers are based on transistors, MOSFETs, FETs, BJTs, etc. So, amplifiers. Now, what is an amplifier? So, in our mind is what is an amplifier. So, if we consider a sine wave like this, so this is a very small signal sine wave, and here we are having different parameters of this sine wave. This is a wave which changes with respect to time, is called as a sine wave. On this axis we are having time. So this is the amplitude, and another parameter of this is the time period, which is capital T. And if we need to calculate the frequency, then frequency is equal to 1 by T, that is reciprocal of time. So we can calculate here. Now, if this type of a sinusoidal wave is being given to a circuit which we are calling here as an amplifier as an input, then what we are expecting at the output. So at the output we are expecting a signal which is similar in shape to the same signal, but the amplitude is being increased like this. So which amplifies the amplitude of a given input signal, then that type of circuit is called as an amplifier. Now, if the amplifier amplifies the current, then it is called as a current amplifier. If it amplifies the voltage, then it is called as a voltage amplifier. And if it amplifies both current as well as voltage, then it is called as a power amplifier. So friends, this was the simple definition of a amplifier, and the next one is the types of amplifiers. There are two types of amplifiers. The first one is the small signal amplifier, and the second one is the large signal amplifier. Now, what are the comparison between the small signal amplifiers and the large signal amplifiers? So, the small signal amplifiers it amplifies only voltage, it is a small in size, no power transistor is being required, and these are used in pre-amplifier or a voltage amplifier. Large signal amplifier, on the other hand, it amplifies current or power. It is bulky in nature, power transistors are required, and they are used in the last stage in power amplifier systems or other circuits. Now, a simple definition of power amplifiers. As we have studied amplify, the term amplify means to increase the strength of weak signal without changing its shape, that is the frequency. And what are the power amplifiers? Now, power amplifiers is that amplifier which amplifies low power audio signals to a level suitable for driving the loudspeakers. And simplest power amplifier circuits is our emitter follower circuit. Input to power amplifier is few microwatts, but the output of power amplifier is in thousands of watts. So, the block diagram of an audio frequency amplifier is as shown over here. So, this is the power amplifier is generally used in public address system, that is this type of audio frequency amplifier, in which the input is given to the mic and the output of the mic is given to the audio preamplifier, and the output of preamplifier is given to this power amplifier, which in fact drives the loudspeaker. So, these power amplifiers are basically used in the public address systems. So, these are some of the applications of power amplifiers. Main application is public address system that we have discussed, theatrical and concert sound reinforcement in domestic sound systems such as stereo or home theater systems, in instrument amplifiers including guitar amplifiers, etc. So, features of power amplifiers. impedance matching with load, that is the loudspeaker. In this case, power transistors are required. Power amplifiers are very bulky. Harmonic distortion is present at the output, and they are capable of handling large powers. So now the classification of power amplifiers. These power amplifiers are classified into 4 types: Class A, Class B, Class AB, and Class C amplifiers. We will go on studying all these 4 types in the coming presentations. Now these power amplifiers are classified according to the position of the quiescent points on the load line circuit. So for a Class A, center of the load line; for Class B, it is in the cutoff region; for Class AB, just above cutoff; and in Class C, below cutoff. So these are the quiescent points where the amplifier has been classified. So we will go on, we will also see the waveforms, in which we will show you the quiescent points also. So the output waveforms in different power amplifier classes are this is for Class A amplifier, in which the whole sinusoidal wave is being amplified. In Class B, only half of the wave is being amplified. In Class AB, in Class C, only a small portion of signal is amplified, and in Class AB, the more than half of the cycle is being amplified. So see, these are some of the waveforms of all the power amplifiers. Now coming up for the first power amplifier, that is a Class A power amplifier. The features of Class A power amplifiers are as follows: the transistor conducts for a full cycle duration, that is 360 degrees. Q point is set at the center of the load line. There is no any distortion at the output. Large power dissipation is there, and similarly the disadvantage is very low efficiency as compared to the other amplifiers. So why large power dissipation is there? Because the transistor work continuously in the active region, and it amplifies the whole of the cycle, and therefore it requires a large power, and therefore it dissipates maximum power. And why it is having a less efficiency? Because the same reason, more power is dissipated, and therefore this type of a Class A power amplifier has a less efficiency. Now circuit diagram and waveform of Class A amplifier. This is the basic circuit diagram of Class A power amplifier, in which we are able to see that R1 and R2 are the base bias resistors to keep this base emitter junction forward bias. This is the input sine wave given to the base through capacitor C1, and R3 is the load resistance which is connected to the collector, and R4 and C2 are bypass capacitor and resistance, emitter resistance. Similarly, as you can see over here, the sinusoidal wave is converted is amplified over here, and one point that is to be noted is the cycle is having a 180 degree phase shift. So the common emitter amplifier gives you the 180 degree out of phase shift. So this is the quiescent point waveform, in which we are able to see that the quiescent point in load line, the quiescent point is set at the center, so that the full cycle is being amplified. So this is the Class A amplifier. The advantages of Class A power amplifier are simple in construction, no distortion at the output, and disadvantages, as we have discussed it earlier, very low efficiency, that is around 25% to 50% only, large power dissipation in the power transistors. So this was all about the Class A power amplifiers. Now the second one is the Class B power amplifier. In this, the features of Class B power amplifiers are as follows: transistor conducts only in one half cycle, that is for only 180 degrees phase. Q point is adjusted to be at the cutoff, exactly at the cutoff region. Crossover distortion is present at the output, no power dissipation, and it has got higher efficiency. So the why zero power dissipation is there, as we have earlier studied, that because due to it works only in the negative half cycle, therefore it has low power dissipation, and in terms of efficiency there, that is why the efficiency has been increased over there. The waveform and circuit diagram of Class B power amplifier. The
Class B power amplifier shows that there are two transistors Q1 and Q2. One is NPN and the other one is PNP transistor that is used over here, and the quiescent point is set such that more than half of the cycle is being half of the cycle is being amplified, and the rest of the half cycle the transistors are switched off, and therefore there is a low power dissipation. So this is the circuit diagram, and that is the waveform of class B power amplifier. Advantages of class B power amplifier is higher efficiency, that is around 78.5%, zero power dissipation, and this circuit is usually used for impedance matching also. The disadvantages of this are crossover distortion is present at the output, and efficiency is low as compared to class C amplifier. So these are the advantages and disadvantages of class B amplifier. Now coming up to the third power amplifier, that is a class AB power amplifier. The features of class AB power amplifiers are as follows. Transistor conducts between 181 to 359 degrees. Q point is adjusted just above the cutoff. No any crossover distortion. Efficiency is equal to the class B, and power dissipation is between class A and class B. So in class A we are amplifying the whole cycle, in class B we are amplifying the half of the cycle, and in class AB we are amplifying more than half of the cycle, and that is why this is the mixture of both, and that is why it is called as class AB power amplifier. So the circuit diagram of a class AB power amplifier is, it is again having two transistors Q1 and Q2, but in between we have connected two RE1 and RE2 to set the quiescent point just above the cutoff region, and we are having the same circuit. So the load resistance is connected across this output voltage, and the waveform is like this. So the quiescent point is set so that this is the small portion of the second half cycle is being clipped, and therefore this is a mixture of the amplifier amplifies more than half of the cycle, and this is the mixture of class A and class B amplifiers. The advantages of class AB amplifiers are elimination of crossover distortion. Configuration is preferred in audio systems, radio, TV, receivers, etc. And efficiency is same as that of class B power amplifier, that is around 78.5%. So, and the last one is the class C power amplifiers. The features of class C power amplifiers are: transistor conducts for less than 180 degrees phase. Q point is adjusted below the cutoff region. Distortion can be present at the output. Low power dissipation, but the efficiency is very high, that is more than 95%. Applications of class C power amplifiers. Class C power amplifiers generally are made using a tuned circuit as a load. It is also used as a collector modulator to produce amplitude modulated signal. So the circuit diagram of class C power amplifier is like this. As you are able to see, there is an inductor and a capacitor which is used as a tuned circuit over here in the collector side, and RFC is used with respect to negative minus VBB voltage and plus VBB voltage. The output is taken across the collector and input is applied to the base, and in the waveform region you are able to see that only small portion of this input signal is being amplified, and therefore it is called as a class C power amplifier. Now the advantages of class C power amplifier are very high efficiency, that is around 95%, and less power dissipation. Disadvantages are output waveform can be distorted, and in this lockdown period we request you to stay home, stay safe and take care. And thank you for watching this video, and also hope that you will subscribe this channel. Thank you very much. Have a nice time.